Another way to describe the frequency of emitted electromagnetic radiation is classically. In the classical limit, the frequency of the radiation comes from the frequency of the accelerating charge. Here we have a nucleus with an electron going around, and this is what emits radiation. In other words, the electron, as it goes around in a circle, is much like the charge inside of an antenna that just goes up and down. In this case, the frequency of the radiation equals the frequency of the electron in orbit equals its velocity over the circumference of the orbit. Now, the velocity over the circumference can be found by using the formula for centripetal force. I'm going to square all of these momentarily and write down that the velocity squared divided by 2 pi r squared equals this expression. This simply comes from the fact that mv squared over r equals e squared over r squared. That's in the unit system where k equals 1. K in MKS is 1 over 4 pi epsilon naught. But in CGS units, k is 1. So here we have a second expression for the frequency of electromagnetic radiation. And it comes from purely a classical case. And it should go something like 1 over r cubed. Now we're going to insert Bohr's formula for what r cubed is. And this expression becomes e squared over 2 pi squared m a naught cubed m to the 6th. So this is a somewhat classical expression with one last minute quantum mechanical insert. Now we're going to set this expression for frequency squared with the expression we obtained from the large n limit of the classical formula. This gives us that the frequency squared is either e to the 4th a naught squared h squared n to the 6th. This is the quantum mechanical formula. Or the frequency squared equals e squared 2 pi squared m a naught cubed n to the 6th. We'll call this the classical formula. Setting these two things equal, as we have, we now find that we can eliminate the integer n, which is n to the 6th in both terms. And we have an expression, a naught equals hc squared over 4 pi squared m of the electron c squared g squared. And this gives us the Bohr radius in terms of fundamental units, or constants. That's quite a surprising thing. That's an accomplishment because up till now, this quantity called the Bohr radius was purely an empirical number, and it had no basis in any kind of